So, hello everyone. My name is Agustin, and I'm here with my friend Pepe. And we are here today to show you Fibric. That is a development that we've been working for the last year in our spare time. It's for doing procedural cloning with curves. First of all, we want to say thanks to the SideFX team for inviting us and for helping us in this development. And also to our families for supporting us in this whole year, that it was a little bit crazy. So let's roll a demo reel, and after that we can kick off. Thanks.
Hi guys, thanks you for being here. Thanks to SideFX for inviting us, FMX for having us here today. I'd like to introduce myself. I'm Pepe Buendia. I'm a Houdini TD based in Spain. I specialize in procedural workflows and technical approaches for creating assets, environments, FX setups, and pipeline workflows within the USD framework. Here you can see one of my projects with Houdini, where I created a full procedural city with traffic system, everything with Vex code and doing in Houdini. I really enjoy creating new tools and to face new exciting challenges. Fibric really was one of them. So I hope you will enjoy. Thank you so much.
Hi again. My name is Agustín González. I'm originally from Argentina, and I'm currently living in Spain. I've been working in animation and VFX industry for over a decade, and where I was leading surfacing and lighting teams on a wide range of projects. In the recent years, I've been taking the role of CG Supervisor, in where I was helping studios to develop workflows and tools to tackle all kind of challenging productions. But over the last 5 years, I've been shifting towards using Houdini, implementing it, and trying to use the flexibility of procedural and many setups for speed up pipelines. So with that saying, let's jump on Fibric. Have a lot of things to cover.
So in this talk, we're going to break down the whole toolset of Fibric. That, as Agustin already said, is a toolset to create clothes with curves. We're going to explore every module and dive in a little bit inside of them to show you some of the techniques we are using with Houdini. So yeah, let's see how Fibric works. We're going to go from actual meshes to see how UVs are an essential part of this workflow. We apply our Fibric patterns and any other modifier on flattering UVs, always. And then we wrap it back to the mesh. One important thing to mention is that we are not sweeping or generating mesh curves. Here we have a viewport preview with OpenGL, but it's the render engine who is going to draw curves at render time. So we are just using open curves as though it was grooming hair. So we're going to see how to create fabric with different patterns, how to add stitches, how to add more detail to the curves, damage the fabric, add fuzz, and many more. And finally, how to deform it and apply an animation to it. So here you can see some renders of a character that we create for showing this toolset. Everything rendered in Karma, of course. So this is Lina. Lina is the character that we did to show what this toolset is capable of. But we didn't do it alone. We had an amazing team. Francesco Guarini as an art director, Borja Lopez Galeano as a modeling and anatomy supervisor, Carlos Velázquez Ayala as a modeling artist, and Rodrigo Hernan Lopez with the rigging. We'd like to thank them for their amazing work in such a short amount of time, from concept to final in just 1 month, with everyone working in their spare time. So thank you so much, guys.
So let's start from the most granular level, that is our pattern nodes. So we decided to simplify the complex world of textiles into two main types of fabrics. That is going to be weaving and knitting. First, let's dive into our weave patterns. In real life, weaving is done by interlacing two sets of threads, a vertical one called warp and a horizontal one called weft. And the structure of this interlacing is often represented by a black and white diagram, where each square tells you if a thread goes over or under another. One last thing about weave diagrams is that they include a repeat ratio. We need to respect these values so the textile structure stays true to the original design. So with the pattern node, we decided to follow the diagram mindset. Here, I'm using the same 8x8 plane diagram, and when I select any image from our library, the pattern will change. Now I'm picking a denim that is a 4x4, so I will need to change the rating between weft and warp, and I can also change the width and also apply some tiling just for pre-visualization that is pretty useful for doing this kind of small patterns. But we are not constrained to use small diagrams. So we are not constrained to use small diagrams. The node can resolve any complex weave pattern. By the way, this pattern is being used in the intro renders, and later on, Pepe will show you an extra feature related to complex weaving. So yeah, you can go online and catch as many diagrams you want, put them in the generator, and voila, you have them. But we also have HDA, powered by COPS, that lets you paint your patterns in live. It's pretty user-friendly. As you can see on the right, we have COPS, and on the left is the curves getting thread. Let's move into knitting. So we decide to have some different approaches. The first we have is a simple weft knitting setup that you can find many tutorials out there from the community, in where we can change attributes like width and stretch the patterns in the different axes, and everything is going to be adapted. Additionally, we create a very common technique that consists in inverting the knit direction in between rows. This is normally used in endings on sweater and many other types of clothes. And we also develop a solution for creating custom knitting patterns. Here, I'm using a curve to model a small knitted ribbon, and after drawing the curve, we can simply connect it into the pattern node, tweak the offset, and the node automatically fuses the ribbons based on proximity. And the last method is called custom pattern. You can think of it as a free canvas. In this example, for instance, I'm using a Voronoi fracture workflow that we will show later in deep with Linus breakdown. But the important thing is that once I plug this into the pattern node, it would get fully integrated and processed by the rest of the nodes of the toolset. So that's pretty much it about patterns. Let's move now into the generator.
Okay, so the second module, or HDA, is the fabric generator. In this module is where we apply the pattern to the meshes. So this module takes a mesh and a collection of fabric patterns as input and wrap the pattern into the geometry. Patterns can have different sizes and settings. For example, we can import both weaving and knitting patterns together. Then the generator will identify each one by some attributes stored in the patterns. The generator recognizes each pattern by its unique name and fits it into the mesh, making sure it follows the surface shape and stays within the mesh boundaries. Here we can also adjust the look of the pattern into the geometry by tweaking several parameters. Users can adjust the scale, rotation, and width of the pattern, and many more. We can also add, for example, some randomness to the width to achieve a more organic look, as you can see here in this example. But of course, this control is not constrained by parameter sliders, but we also support the use of textures or maps. For example, the feature width from map allows you to create some sort of transparent areas in the cloth using different shapes like this floral one. But we can go even further in the case of weave patterns, and we can completely replace them doing the weave by a black and white signal in the map. So we give users full control over the weave structure within the generator, helping to achieve a more a more custom result. We can also merge multiple patterns at once in the same generator. We could create new entries within the multi-pattern block and select a different pattern, and then by selecting the area of the mesh where we want the pattern to be applied, we can mix multiple patterns, having full control of each one of them, and tweaking the settings, scale, rotate, or whatever, affecting only the selected area where the pattern is being applied. Okay, so now we're gonna dive a little bit inside the HDA to see what is really going on. Okay, as I said, we're gonna dive a little bit inside the HDA to see what is really going on. All this toolset is based on the UVs of the mesh, so we have to be careful of the UV island size. This is just an example to show you, but in production it happens all the time that texel size is not normalized. So for those cases, we have two modes, real-life scale and UV scale. As you can see with the UV scale, we have mismatching in the scale of the pattern through different islands. So real-life scale is gonna solve this problem. To solve it, we just need to adjust the UV island size to match real scale of the mesh. So we need to split the geometry by its UVs and transform the UVs to 3D space, and then adjust the size and align them together. For that, we measure the area of each island with the Houdini measure node, area of the UVs, and we compare it with the area of the real piece of cloth. We get the scale ratio by dividing the square root of the area of each island by the area of the real piece of cloth, and just by multiplying that ratio by the position, we get the proper size. Here you can see the result. After that, we just need to align them to avoid further intersections. So once we have the adjusted islands, we have to iterate one by one, applying the pattern to it. We are using compile blocks for that task to improve the performance of this process. As you can see here, we got the island and we got a pattern that had been repeated as much time as needed to match the scale indicated by the user. It is already placed on top of the island, so we just have to cut what is outside the boundaries. For that, we are using the vex function xycdist that returns the distance between a point in the space and a prim. And we are basically removing everything that is beyond distance 0. So yeah, now we have every pattern, different pattern applied to its corresponding UV island. Okay, so the next HDA is the one to create stitches. Stitches are a very important module of our toolset, so we try to be as flexible as possible for this one. We have 3 different ways to create stitches. First one is to just select some edges from the geometry, so a stitchet would be created following that curve. Also, this HDA has several types of stitches built in that fits for most of the cases. We got the basic, cross, feather, zigzag, also simple line for custom scenarios. But we also have the option of create more complex type of stitches. I mean, it's not really a stitch, but lives in the same HDA for convenience. They are the brace. And you can see how it's improved a lot the look of the sweater, for example.
Yeah.
Also, of course, a lot of parameters could be tweaked or randomized to improve the look of stitches. Random rotation, scale, stretch, or width are just some of them. You can tweak as many as you want. After finishing the look, you can go straight and keep selecting more edges with that same look. The second way of creating stitches is to draw curves directly on top of the geometry, using, for example, the Houdini node draw curve. Just by enabling the external curves mode on the HDA and picking the curves, we got the stitches. We could even try to draw in real time on top of the Fibric, but of course, the performance getting worse while we add more curves because several calculations are being done to avoid intersection with the Fibric. That's why we added a preview mode where you can draw in a very more responsive way with a low-res geometry. The last way of creating stitches is to draw them directly on top of the UVs. In order to do it, we need to highlight the third output of the stitches so we can display them and draw on top of the same way we did before, but now using the Houdini node curve. But this workflow is not constrained by just drawing curves. We could also place some custom curve pattern on top of the UVs, and it will work as well, as you can see in this example. So again, we're going to dive inside the HDA to see the most important aspect of this setup. First thing to do is to calculate the orientation of the curve, extract the centroid of each edge. Then we have the stitch sample, and we just need to instance into the curve. Once we have the sample already instanced, we have the option of connect them to have a more realistic approach, having a front face and a back face. And we're going to see it in a moment. So now we have the stitches, but they still flat. So what we need to do is to apply the exact amount of offset that we need to match the width of the fabric and avoid intersections. So first, we unfold the fabric and we flatten it in the Z-axis, but we store the Z position. And that's because we are going to perform a search with near points function. What we are basically doing is to look for a bunch of near points, and we get the maximum and the minimum height of the fabric. So this way, we can offset the stitches properly. Finally, we have another feature that allows us to affect the geometry under the stitches. Let's imagine we have some really big ones, and we want a more realistic look, so we can enable the affect fabric. So now the curves of the fabric below the stitches are getting affected by them. And here you can see how this effect really changes the look of the fabric. With this, the idea is pretty simple. We just got the stitches and we isolate their middle points. And then within the fabric, we look for the nearest point and calculate a vector that goes away from it. So we offset, and so yeah, now we have some sort of integration between the fabric and the stitches. So after generating the fabric and adding some stitches, we can add another level of detail to the clothes. So for that, we created the multi-fiber HDA that increased the number of threads per curve, interlacing them while respecting the width, creating some sort of ropes. You can stack as much multi-fiber iteration as you need, tweak the frequency, even add maybe another layer of multi-fiber to the current one. And here you can see a render and IPR in Karma in real time, how to multi-fiber change the look of the clothes, giving a way better look. So let's see how we are doing that inside the HDA. First, we got the stitches, for example. We are using the sweep node to add more curves, and we are adjusting the width, and then we roll to interlace them. So for that, we need a cross-section for the sweep. We have as many points as curves we need. It looks a bit weird, but it's going to make sense just in a moment. To achieve that, we are doing it in a way that, I mean, for sure, not the best way, but you know, Houdini offers you a lot of ways to get the same result. So we have a circle and we scatter some points with a big relaxed iteration value to make sure they add as much equidistant as possible. Then we calculate the scale of each point by its distance to the nearest point. So what we get is if we instance some circle now and we increase the number of points, they're gonna be always trying to fill the available space without touching each other. So after having that, we just have to extract the centroid of each circle. We recalculate the scale and connect them randomly. And then we have our geometry that looks very random, but the only thing we really need are the points because we are doing the sweep in column mode.
So now let's take a look at the simple but effective model, that is the displacement one. So this HDA is working pretty much like a displacement shader, and where by loading images, we can displace the curves in the z-axis. And it supports any kind of displacement workflow. Like in this case, I'm sculpting some faults in ZBrush, and then importing the texture back into the module, and it's working. It's pretty straightforward. Or we could also use Copernicus for doing these kind of things. So this setup is not something that is coming with Fibric. It's just Copernicus and SOPs working together. But it could be fun to see something that can be workflows from Houdini mixed up with the toolset. So let's take a look at the setup. So in COPS, I'm importing the mesh with a SOP import and rasterizing the geo in UV space to get a black and white mask of the UV islands. Afterwards, I'm using an iconial node to create this kind of distant/bevel mask. And then I'm going to be creating a vector with a height to normal. And this vector is going to be helping us to align the faults later. So back in SOPs, we need to create the points to stamp the faults. And for doing this, I will flatten the mesh with the UV coordinates and also create a border group with the edges of the UV islands. I'm also bringing back the vector that we just created in COPS. And I use Vex for creating a sprite rotation attribute that the standpoint node in COPS will need later. Then I use a convert line with a dissolve with the border group that I created before. And then I will add some points with a scatter node on those edges. So finally, in COPS, we can import the scatter to feed a standpoint that is already reading the sprite rotation. And we are also instancing a flattened circle shape that is going to be giving that hairy, that doesn't look like faults yet. But the last touch is being given by a blur node that uses a soft SDS mask from the UV mask. And if we start to push the blur, you will see that those weird things can start to look like tension faults, we can say. And then if you apply it with the displacement node into a Fibric primitive, you can see how maybe some parts are looking like tension faults. The cool thing about this is that you can use any mesh that contains UVs, and it's going to be adapted. You don't need to touch anything.
Okay, so the next HDA we'd like to show you is the damage. This module is the responsible to break the clothes, adding noise and tearing. So let's see how this HDA works. We have two ways of adding noise. First one is adding the same noise to the whole set of curves. And the second one, we are adding noise, but we are offsetting the noise by curve. This way we can achieve a very different result, I'll say more organic. And of course, we can mix both of them. So this HDA can also tear up the clothes. It takes a mask from an attribute or a texture and allows the user to perform some tearing. So after painting the mask, first of all is reducing the width of the curves and removing points that had a width of 0. We can here also add some noise to it using that same attribute or any other one. Also we can add some fuzz on the tear edges, and the fuzz is following the shape of the damage area. And you can adjust the density, the length, and many other parameters. Here you can see a real-time IPR of Karma, of how the damage can change the look of the cloth. So now we're going to dive a little bit inside the SDA to see how we are doing the fuzz edges that have it following the shape of the tear area. So first of all, if we jump inside, we have the mesh. And we have the mask with the damage attribute applied on the geometry. So we need to calculate the gradient vector based on it with the measure node again. So as you can see here, this vector is facing the lowest values of the mask. So we just need to invert this vector, and we're gonna use it as our normal vector. So if we scatter some points, we already have the direction, so we just need to tweak the length, add some curves, then we just have to add some width to it, finally add some noise. So just like that, you can have some fuzz in the tier edges following that same shape.
So now let's take a look at the standalone fuzz module. We developed this HDA to procedurally generate tiny hairs on top of any fabric or stitches, and this will add an extra layer of realism and softness to the cloth. This could be compared with the hair generate kind of workflow, but we added some minor stuff on our side. So we can randomize some parameters to have a more organic look, and also we can use any kind of mesh attribute or texture to override them. For example, here I'm using the curvature to concentrate the density nearby the edges of the mesh and also remap the length. I don't know, like trying to emulate some kind of tension damage, we can say. Lastly, we also add some edge fuzz, similar to the solution that we previously showed with the damage module. The only difference here is that the fuzz will be created on the ending edges of the mesh and not around a damage mask. An extra cool thing to mention is that we are transferring the UV coordinates from the below products to the fuzz, and because of that, we can apply the same shader and textures to all the primitives to achieve kind of like natural and seamless look. But at the end, it's like pretty fun, I can say.
Okay, so we already saw how to create fabric clothes, but now we need to wrap it into an animation or a scene. So the last HDA we're gonna see is the one that we have been using in every other HDA of this toolset, and it is the Fibric deform. So once we have done our clothes, we want to apply an animation to it. There is only two things we need in order to wrap it. First is that animation UVs has to match with the UVs of the geometries that we use to generate the fabric. And the other one is to have a rest position of the T-pose of the geometry. So as you can see, if those things are done, we can deform our clothes. This video is speed up 4 times, but it's not really a heavy process. But also could be the case that we have a different simulation. For example, a scene with tearing. So if we try to just use the deform by default, what's going to happen is that, of course, curves are being stretched, as you can see here. So our solution was to add a tearing option to the HDA so we can break those curves. So what we are doing is the tearing is calculating distance between each point and its neighbor before deforming. So we detect when the distance is higher than it was, and we remove or dissolve those curves and points. We have also a threshold to tell the HDA how much stretch we want before breaking the curves. So then if we run it again, we can see how it's working as we need to, but it's better to see it in a render. In addition to deform the fabric, we can also transfer some attributes from the geometry to the curves cloth. The one that is mandatory is the velocity for motion blur, but we can transfer any other attribute from the simulation. For example, here we have a burning scene where the cloth is being teared up, and it has an attribute called burn that follows the fire. So we can tell the deform HDA to transfer it to the fabric. This way we can have seam attributes and use them in the shading of the fabric or anywhere else. And as you can see here, we are using it to change the color of the cloth just as a preview. But again, it's better to see it in a render.
Yeah, and we are also changing the width, I think.
Yeah, here we are transferring this attribute, and we are changing the width and also adding some noise with this mask so we can match the look of a real cloth being burned. Well, with the deform, we already have something that you can work with and create some Fibric clouds, deform them, and cache every frame to disk. But as you can imagine, caches are pretty heavy. I mean, not more heavy than a standard grooming for a hairy animal, for example. But we wanted to find another solution to make this workflow really performant. And that's where USD render time procedural enter the scene. For those who are not familiar with this term, is USD processing executing some process in render time. So inspired by the Husk procedural that SideFX developed for generate and deform hair, we decided to give it a try on creating our own render time procedural, of course, based on the amazing work that SideFX team did with the hair one. So as you can see here, we are in Solaris context with all the clouds already imported. We have a clone of our Fibric deform, but now it's working as a render time procedural. So we just need to tell the HDA what primitives are the ones to be deformed and what are the primitives geometry to guide it. So here we can also tweak the same parameters of tearing that we saw in the deform module. So after setting all the parameters, we can check if it's working with the Houdini preview procedural node. Remember that this is only a preview, so we don't need to cache it because the procedural is going to resolve it at render time. Now if we jump between frames, we can see how the procedural is doing its job. Okay, so let's see a little bit of how we are doing it. First step is to create a subnetwork or a compile block with the node graph working in subs. Because what the procedural is doing in render time is executing subnodes. So as you can see, we have the same behavior that we had in the deform SDA. So next step is to use the Houdini node attribute from Parm that store all the data of the node graph in a really interesting and clever way. It is creating a point for each node and an edge for each node connection. And if we take a look of the geometry spreadsheet, we can see how in each point we have the node name, all the params, and other data. So once we have the graph converted to geometry, we can check if the procedural is working with the Houdini node invoke graph. So with the same inputs and using now the geometry graph, we get the exact same result. As you can imagine, the geometry graph is what Karma is reading in render time to deform Fibric clouds. We'd like to thank to the SideFX team for their support on this one, especially to Rob Pieke for answer all our questions about the render time procedural with USD. Okay, so here you can see another render using our render time procedural, transferring a mask from a fluid sim to the Fibric curves.
Pretty cool. So that was all the modules, and now let's jump into linear breakdown, where we've been using Fibric for doing all the clouding on the asset. So we started from the concept art of Francesco, and the model was built without any restriction. It's pretty straightforward. Fibric just requires, as we mentioned, just UVs. Since that Fibric is contributing so much with the final look of the asset, we decided to work with it at the same time as we were doing texturing and shading. So it was all happening in the same heat file, and we've just been jumping in between Solaris and subs. We've been using Substance Painter for doing some basic texturing and mask, but the good thing is that we don't need that many UDIMs or texture resolution for the cloud, because Fibric will help us later with all the fine details. So let's take the pants as an example. Here, we start by painting a mask to separate two different patterns. Then we can add some displacement in between them. And finally, we paint some dirt mask to support the Lookdev later. All this is going to be packed into a single 2K texture, and then by using RGB channels with the IDs, we can separate them. Then back in Fibric, we use the mask in the generator node to assign different patterns with their custom width and repetition and any kind of setup. We are also procedurally creating these seams with the stitches module, and it's set on image base. And by selecting the red channel of the previously painted texture, we can scatter those stitches all over the pants. After that, it's just about adding modules on top of the cloth, like multi-fiber, displacement, the tearing, the damage, and at the end, some fuzz that is going to be giving the soul, right? Because it's not just a pattern, it's clothing. We can take a look at this in Karma. In here, I'm going to be doing something crazy. That is, I have the IPR on, and I'm disabling many of those modifiers, and Karma holds up pretty well. Don't do this at home, please, unless you use Karma, okay? So with the share, we use the same mask techniques for mixing the patterns and also to create the stitches. But we also decided to use the texture mask in combination with the damage module to have a more artistic and fine control on the tearing parts. We created this kind of lace pattern that is powered by a combination of SOPs, Copernicus, and the stitches module, and also the Voronoi fracture node. Let's take a quick look at the setup. So first, we have a painted mask that then we are loading it into COPs and extracting the blue channel and creating a soft SDS mask. Also, I'm mixing both masks back. And then in SOPs, I will blast anything outside of the red channel that is the hard mask. And we're going to be casting the soft mask into a density attribute to use it in the scatter node. And here we can see how the soft mask created with the SDF nodes is helping us to remap how many points we will have from the borders to the center of this kind of tentacle shape, we can say, or tribal. And then by creating a simple grid and using a Voronoi fracture node with the scatter points, we have this kind of result that then we can clean it with some Boolean and fuse to end up smoothing the points to have some sort of like relaxed look. The last touches are getting done by the stitches module by using the painted mask from Substance to create the seam borders. And then once we fit the Voronoi setup in the stitches node, this is the result. But if we go back a little bit, we can also draw a curve in the center, keep the points, then I can combine it with the scatter, and now I will have a more like a tentacle kind of shape over there. This is simple Voronoi logic, but it's pretty fun and it's quite flexible. Let's talk about the cape. So the cape is a little bit special because we decided to use double-side meshes to create a composite-style fabric that allows us to assign different textile for the interior and the exterior parts. We leverage the whip by image option of the generator node. This is great for doing this kind of jacquard textiles, but we also use it for creating some straight kind of embroidery for the school logo. At the end, by adding some stitches, is the final ingredient to have it like pretty organic. Now let's take a look at a very good example with the damage module. So let's see a very cool example with the damage module. Here I'm adding some overall imperfections, and then I'm painting a tear down attribute for tear down the fabric. Yeah. The beauty of the damage node is that the destruction will happen seamlessly for all the primitives from Fibric, but yeah, as you can see here, the interior part is not getting affected. It's a little bit weird. But actually, that's because the size of the volume brush wasn't big enough to paint through the planes of the meshes. So by making it bigger, I can paint through the planes, and everything now will get destructed. But actually, with a quick lighting test, we can see that both versions are okay. It's all about artistic decision, and the important thing is to have the control to achieve them, right? Because so the first one is more translucent because you still have one layer. The second one is full destructed, and you can see through the cape. So in another example, the stitches module have a standalone mode that can work with any mesh, so it's no pattern needed. I can use the edge selection node, and we have stitches like really fast. I'm also using the COPS preview material node to pre-visualize the textures that I output from Substance Painter with the stitches on top. This is pretty cool because you can have an idea on how this is going to look later. In one of our concepts, we have this herringbone kind of pattern that we wanted to add with stitches. So for doing that, I'm using the UV flattened mesh preview with, again, the COPS preview material to see where I am. And then I'm drawing the first square of this pattern, and by using a copy node, I can repeat it as much as I need. And then once I fit it into a stitches node, that is what we have. So if we take a look in Karma, we can see that the stitches are there. Everything is okay. But something is odd. The thing is that we are missing some tension and pinch from the stitches to the leather. So to improve that, let's use Copernicus. I will send the stitches into a standpoint node, and after that, I will blur the result to create some sort of like bulge mask, we can say. In addition to that, I'm using the root points of the stitches with a separate standpoint to create a contact pinch. After that, I will export the texture, and then I can import it in Material X, in where I can mix it with the pre-existing normals from Substance Painter with this new bump. And if we now trigger Karma, that's how now the stitches are like looking way more adapted, we can say. So now let's talk about how we look the Fibric in Solaris. So for achieving this kind of translucent result, we are using the Karma hair shader that is based on the Xiang model. So our shaders are full specular, and we just add diffuse when we wanted to have some dirt on top of the cloth. Another key aspect of Karma hair and Fibric is that we need to tweak the normal roughness and the azimuthal one separated to have a better artistic control. Here we can see how low azimuthal values will make the curves look more translucent, while high values will absorb less light. And here, on the other hand, we can see also how controlling the normal roughness will change it and make it more glossy or more rough. Fibric outputs some useful primers, like this one that is a mask in between weft and warp, and here I'm using it to colorize some horizontal threads. And finally, we can make usage of those ID textures from Substance to apply some dirt on the final shader. So for this last example, I will change the design of the glove to something more graphical. So if we take a closer look, we can notice that the wool fibers are getting colored like if they were tinted and not knitted with different color yarns, like in real life. So for these kind of approaches, Fibric outputs a second UV set that samples the center of each ribbon to converge it into a kind of integer coordinate UV value, we can say. It's pretty much like pixel art with knitting. Yeah, so it's really fun. You can see some well-known characters in knitting. And about performance, in the final asset, Fibric shaders were using just 13 2K textures. And if we compare it with classic texturing pipelines, by just adding the standard PBR channels like base color, roughness, normals, etc., the amount of textiles could go to 46 files in 4K if you wanted to have like a hero character. But even though this is just this quick test that we did, it's just by using the same UDIMs, we can say UV tiles amount. But if you wanted to have a hero character, you will need way more UDIMs, to have a really good resolution. And finally, the render times of the shots presented today are amazingly good. None of them were using any kind of denoising. It's all pure Karma XPU. So for the white shot in where Lin is walking, my RTX 3070 is on 90 seconds per frame, and RTX 4090 is on 40 seconds per frame. And the close-up shots are in 4 minutes on my 3070, Porsche 3070 at home. I love you. And the 490 is on 2 minutes per frame. That is quite fast. And the final poly count of all the Linus Fibric products is on 500,000 curves, more or less, and 9.3 million points. So by saying that, we can say thank you so much for joining us today.
So because we have two people talking, we don't have a roaming mic, so we'll have to get you to call a question, and then they'll repeat the question into the mic. So you'll repeat the question into...
Yeah, okay.
The question.
¿Quieres sacarlo y poner la primera línea?
You've been working a lot on the presets for like jeans and cotton and linen. Do you also plan to include some texture presets, perhaps, so for different types of like let's say, silk or jeans is quite different?
So yeah, the question is that if we are delivering different presets for different types of textiles, we can say. Yeah, actually, we have a small library that we've been using of diagrams that we've been using for the development, in where we have like, I would say like 25 of the most common patterns. And I think that over there we have all of the standard ones. But the important thing is that the diagram idea is actually really open for anybody to, I don't know, if you find, this is, in one of the slides I show it, if you go into the internet and you find a diagram in a book from 50 years ago, snap it, put it on the pattern node, and you will have it. So actually that's the fun part, right? Thanks, good question.
Somebody over here.
How do you plan to like expand on the system current setup that you have, including like different kinds of cloth, for example, crocheting or sort of crochet instead of knitting or weaving, or if you?
Yeah, I can grab that one. Okay. Yeah, so the question is that how we can expand this for different types of clothing that are not just weaving or knitting, right?
Yeah.
Okay, so in one of the slides in where we've been talking about knitting, we have one of the solutions that is called the custom pattern, in where I showed like that texture of tentacles created with lace or something like that. And that solution, the custom pattern, is a free canvas. So the good thing about Fibric is that we are lefting the door open to anybody that brings any idea in Houdini, can plug anything that is created with curves, and it's going to be wrapped into a cloth. And then after that, you can apply all the modifiers, multi-fiber, destroy the cloth or whatever. So the basic idea is that, you know, we've been analyzing, for the last year, actually doing this whole development, we've been trying to analyze and do the research of, let's do this, let's do that, let's do embroidery. We didn't talk about embroidery, so it's a big elephant in the room. Please don't, I'm joking, but the thing is that it's an infinite world of textiles, right? So the best option for us was to bring an open tool that can let you do whatever you want if you have the knowledge.
And Houdini.
If you use Houdini, yeah. Thanks.
So first of all, very impressive.
Thank you.
Thank you.
Much. And just one question, so just a rough estimation, how much did you put into research and then actually developing these things, and then also how much took it to get the final character, just, I mean, the tools on, I mean, not the character itself, but all the fabrics on top.
Okay.
You want
The research. So he's asking how much time we put into research into developing, and then you can ask the next. I'll say 50-50. We did a lot of research of a lot of tutorials of the community doing similar things with knitting and mostly knitting, but also weaving. But for example, for the denim, Agustin did a lot of research to find out how denim is really working. So when you tear out the denim, you can see only the white cores or fibers that are there. So yeah, I'll say 50-50 research and development.
I've been visiting my mother-in-law a lot for the last year, in where I was watching at her wardrobe scene. No, I'm not joking.
Yeah, one day he said to me, I just realized how invert knitting is working because I'm in the house of my mother-in-law and she has a sweater.
On this last year, my wife found me weirdly watching wardrobes like this, It was that's the research, definitely. And then for Lina, I think that you mentioned it was 1 month entirely since the concept and the final result, the renders, okay? And the execution of Fibric for Lina, it was 2 days. But I'm one of the developers, I know pretty good the tool. But the good thing is that, it's not, as you might notice with the modules, it's not something that is like too open or too complex. It's actually more artist-friendly, where if you have a good concept and a good idea on how this should look, it's going to be helping you to stack everything to make it look as you want. Thanks. So.
Are you planning on a way to there's a lot of commercial with the Fibric tech unwind on it and then just anoint the fabric. I don't know if I'm clear about that.
Sorry.
Pull the string of the fabric and it basically unravels the
Like to use Fibric to do like more like textile, really granular commercials, right? Like, actually, you can do whatever you want because once you have the pattern wrapped to any geometry, right? Then you can apply any node from subs like the carve node that is going to be helping you with that, right? So you can think of it as an open tool that once you have the curves over there, you can do whatever you want. Yeah.
One of the great things that I love about this use case is that it shows how Houdini can be used by a technical person or team to create these tools that can then be given to a less technical person who can get started with Houdini more quickly to make it creative work. So,
Yeah.
One last question, since I mostly work in Marvelous Designer, so
Yeah.
I take all of the Alembic files of that. Was the model that you used there, was it box modeled or was it also like an Alembic cache from a software that is actually used to create these patterns?
You can. The question is that if we can use any kind of mesh. You said, right?
Alembic in this case.
Alembic. So you can use whatever you want. One thing that we didn't mention that is quite really good for Marvelous Designer users is that Fibric doesn't need any retopo. So that's, I know.
That was the question.
Yeah, that was the best. So the thing is that the only thing that matters is UVs. So it needs to be good UVs. Actually, Marvelous outputs really planar UVs. And another important thing is that UVs shouldn't be overlapping. So after that, you can bring anything. It could be triangulated, it could be retopo, and then Fibric is gonna be able to work on top of it. And then if you have a simulation from Vellum or Marvelous, sorry, side effect, you can use our render time procedural to wrap it into to wrap the fibers, okay, Fibric on the simulation, and you will not need to cache it. So that's the cool thing. No, you're not going to be killing your storage with that. Thanks.
Yeah, question. So, for the simulation of the actual underlying cloth, you would still use Vellum?
Yes.
We need to set the question. So
Sorry. Yes, if we are using Vellum for the simulation of the cloth. Yeah, absolutely.
yes, we are using Vellum. Always Vellum.
Always Vellum.
all right, guys. Well, thank you very much. Really cool.
Thank you.
Thanks.